Why is manufacturing important? Well, everything that is mass-produced is manufactured. In the scheme of economic impact, 76.8% of the U.S. economy is made up of the service industry, restaurants, hotels, banks, and all of these businesses, uniformity is key, which is created by mass production. Therefore, a breakdown in the manufacturing industry would impact at least 87.3% of the U.S. economy, with 10.5% being technology. As our team researched the broader topic of the manufacturing industry, we found the three main challenges: supply chain malfunctions, troubles with technology integration, and the breakdown of cybersecurity for companies that were already well digitized. While all three of these issues have the potential to materially damage a manufacturer through loss of material and intellectual property, a loss of time, as well as damage incurred to the manufacturer-customer relationship, in the end we determined that the issues pertaining to the integration of technology were the most important because in many ways, cybersecurity and supply chain communications fall under the umbrella of technology integration. A large area for growth in the manufacturing industry is management and creation of digital systems. In the coming years, the management of IIoT is predicted to grow 10.9%, or increase the jobs by 57,000 jobs between 2020 and 2030. Historically, the integration of technology and inventions has propelled the industry forward into levels of efficiency that the global market becomes reliant upon. The first was in the first industrial revolution with an addition of steam power, then the second industrial revolution with the addition of electricity, the third with new kinds of actuators, sensors, and programmable controllers, which brings us to the fourth industrial revolution, or Industry 4.0, which is driven by an emergence of AI and widespread data analytics, as well as the increased efficiency of sensors and modeling programs. With that being said, the true driving force of this stage of Industry 4.0 is the gathering and processing of data collected by these advanced and precise sensors. This push towards big data is well displayed in the 48 billion devices that are connected to a cloud service that carry out manufacturing tasks every day. Manufacturers. As IIoT progresses, cloud-based supply chain relations are expected to rise to 80% by 2025, leading to a 15% increase in productivity and a 10% increase in cost efficiency. On the other end, increased retrofitting of older machines is expected to make the machines turn out 20% more products than before, mostly due to reduced downtime from an increased usage of predictive maintenance.
Our main challenge is the integration of new technologies, whether physically or digitally, in manufacturing. Technology integration is what translates company research and development into productivity and speed. The process of technology integration is critical to competitive performance, but the problem is that most effective ways of organizing and managing projects have already been adopted, and organizations that choose the wrong technologies will run into problems regardless of other factors. This first figure shows that current manufacturing systems lack many components and functions compared with smart manufacturing technologies needed for Industry 4.0. In the technology selection process, technology selection models have been primarily developed to assess mainly financial benefits, which is limiting. The technology selection process fails to incorporate risk calculations, the threats associated with technology alternatives, and existing technology selection processes do not provide support for the inclusion of interorganizational factors, so certain pathways need to be taken in order to achieve more smart manufacturing methods. In terms of the opportunity costs, there are certain challenges with security, with most systems now sharing information via the internet, and new protocols have to be developed to ensure network viability. System integration, which is the compatibility of existing devices to new devices, which can cause various problems in implementation, and interoperability, which is the ability for different systems to understand and access each other's functions independently. There's also safety and human-robot collaboration, the main consideration being occupational health and safety. Multilingualism, which is the smart manufacturing system's way of handling operations between human and machine language, and then return on investment, adopting these new technologies and recuperating a gain. And now we also have a recording with Dr. Saldana to talk about interoperability between machines and humans.
One big challenge is how do you design your controls so that you can ensure safety? And those controls can include everything from if you look up kind of the definitions, administrative engineering controls are very common classes of controls that you can bring in as a person who's interested in bringing technology into the facility. So I think that's a pretty good example of some challenges for bringing in this idea of machine and people coordination.
To showcase how digitalization of manufacturing technology is an advantage to companies, we're going to use GE's digital and-on system as an example. First off, what is the and-on system? The and-on system is a component of the Toyota production system, which is an idea to increase efficiency in order to remove all waste from the production system. The system is important for Jidoka, which is classified as automation with a human touch. Years ago, the and-on system was a cable above the production line that operators would pull in order to indicate there was a defect or an error in the process. This would then notify the manager for him or her to go and see what the issue was and then investigate and problem solve this issue. Like many other companies around the world, GE has adopted this idea as well within the production system. By integrating lean manufacturing principles and advanced digitalization, GE has been able to refine production even as their technology has become more complex. Take GE's Hino plant in Japan, for example, which specializes in manufacturing products from large medical scanners to small precision equipment. They have decreased their lead times by up to 65% for some of their products. This also includes decreasing waste, errors, and downtime by being able to identify these faults ahead of time. Using digital technology also allows companies like GE to gather data on their production lines. So if we have these signals digitalized, what can we do with all this data? Well, digitalizing production and gathering this data from various signals allows us to see clearly how the plant is running from stage to stage and from machine to machine in real time. There are also displays that can create visualizations for operators to notify them when a machine needs a tool change or if the machine is experiencing downtime. Moreover, engineers can then take this data and use analytical tools like Power BI to interpret the signal readings and find areas to Kaizen, which refers to continuous improvement. By being able to begin asking questions like, why is this machine faulting so many times? Or why is this tool life for this machine not meeting the specifications of that tool part? Engineers can start implementing improvements along the production lines to decrease defects, downtime, and waste along the entire production cycle.
Okay, now we'll be talking about solutions to technology integration. To solve these issues, we have done extensive research and our proposal is in two subparts. We would need to gain greater visibility regarding the manufacturing data through effective data management as well as migration of data to the cloud. By consolidating our data together, we can get greater visibility on the company's manufacturing process line. This improves efficiency as well as enables us to identify the most inefficient weakness in the entire process. Having the company's data also enables much easier syncs with third-party suppliers, as well as enabling a secure and reliable environment. This gives companies the flexibility to scale up their operations through multiple plants. Here, we have an example which shows the global facility insight on data management. Companies could gather data not only in the manufacturing plants, but also through customer sites and global operations in order to get a full picture of the business. In order for manufacturers to invest money into expensive digital technology, they need to change their perception on how much risk and reward they could get from this investment. Huge opportunities can arise in the manufacturing environment to improve quality and have a competitive edge over competitors. Most manufacturers are also just looking at cost analysis for the benefits, but they're not taking in consideration of risk assessment if they do not implement technology today. These threats are especially crucial in our time today. For example, not having commitment to innovation as well as inadequate technology might have a huge detrimental impact in the next 5 years. These risks have to be taken in consideration so that companies are aware of the need to implement digitization to their manufacturing lines. So for example, here we have a risk-adjusted strategic value table for technology alternatives. We have 3 different kinds of technology. One is a robot-based technology, a server-driven technology, and the existing technology that we have right now. And there's a survey that asks 300 technology managers to evaluate the opportunities and the threats based on these 3 different technology alternatives. So if we only look at the opportunities that the companies would benefit, in terms of the manufacturing environment, the robot-based technology would be the best choice. But if we look at it based on the opportunities minus the threats, which are also an effective, way to kind of avoid the company being irrelevant in the future, we see that the server-driven flexible technology is actually much more effective at 0.39 weight over 0.33 for the robot-based technology.